Okay, so we're on page 11, and hopefully you have your Chromebook awake. We're going to be using the internet in a minute. Let's all hope that the Wi-Fi is cooperating. So all the lessons that we've done this year so far, for the past 3 weeks, have been leading up to this lesson. So one of the skills that it's really important that you have if you're going to do any other math beyond this is being able to graph a function. So the first thing we had to review is just basic graphing. So how do we just put down a point? Then we looked at continuous functions. So instead of just having a few points, we were looking at, well, what happens when we connect those points and make lines or curves. We talked about the most common functions that we know, and we're going to rely on this today. We need to know the basic shape of our graph if we're going to successfully graph it. Then the last element of that is knowing how to plug in a value to your function so that we can actually make a graph. So that's where we're starting on page 11. We're going to connect how we would use this table to make this graph that they've already graphed for us. So step one is to recognize what kind of function this is. So this guy is a root function, and I know that because of the square root, which means that he is going to, or it is going to have this basic shape. He's a firework, or it's a firework, because of that root symbol. Well, what did this plus 5 do? I know from one of our previous lessons that this plus 5 shifts the graph up by 5. So specifically, it moves your vertex. We haven't really talked about that word yet this year. It moves your vertex to 0, 5. And then I know that this guy is supposed to be an arrow, so I'm going to put that arrow on so that he actually looks right. So I'm not surprised that this looks like a firework, and I'm okay with the idea that it's been shifted up from 0, 0 to 0, 5. So what I mean by this is your parent function. He's usually at 0, 0. We moved him up to 0, 5. Well, how we would get this graph is we would plug some values into the function. So for this first one, we would put -4 in a root and add 5 to it. We would put -4 in a root and add 5 to it. Part of the reason that I want you to have your Chromebook today, and if you like this better, you're welcome to use it for this every day, is that these functions are a lot easier to calculate in Desmos. So I'm going to go to Desmos on the Windows side of the room, and if you want to go to Desmos so that you can watch me plug these in, you can. So on Desmos, I'm going to click the Math Tools, and I'm going to choose the Scientific Calculator. So if you click the Math Tools at the top and you choose Scientific Calculator, that's going to allow you to evaluate these much easier, in my opinion, than your calculator does. So you can see on the keyboard, 3 down is the root symbol. So I'm going to hit that root symbol. I'm going to type in my -4. And then I need to arrow out of that and hit the +5. And Desmos is not giving me a value. If we plugged it into your calculator would give you an error. Because turns out we can't have a negative root. This is not allowed. What this actually equals is 2i, an imaginary number, +5. The root of -4 goes to 2i. So we can't graph that. At -4, we can't put anything on the graph because we get an imaginary number. And it'll be similar for -1. If I plugged in this -1 and then added 5, Desmos and my calculator would just give me another error. So this one is I plus 5. And it turns out that the very first point that we can actually plot is this vertex. If I plugged in a 0 to my function, the root of 0 is 0 plus 5 is 5. So at 0, the function gives us 5, which matches a point of 0, 5 on the graph. And we already have that graphed right here. So one thing that this is telling us is that there's a reason why this firework has this closed point. Because we can't graph anything to the left of that point. Because negatives aren't allowed in a square root. So that's why our firework is one-sided. It doesn't have 2 arrows because we're not even allowed to go to the negative side. And then that also helps me kind of understand that this is like where my function starts, and I'm getting that from evaluating the function at x is 0. Okay, then the next ones, it's very similar. So if I plug in a 1 and add 5, the root of 1 is 1, plus 5 would be 6. So at 1, the function is 6, which means we should see a point on the graph that's at 1, 6. So if I go to that on my graph, if I go over to 1 and up to 6, I do land on that firework. That is the point 1, 6. So I do end up being on the graph for this. The next one, root 4 plus 5. Well, root 4 is 2, plus 5 would be 7. So at 4, the function is 7. We're just going to verify then that we have a point at 4, comma 7. So if we go over to 4 and up to 7, we do have a point on the firework. And then it just wants us to check one last one, but this one you really should plug into Desmos because you're going to get a decimal. This one is not a nice number. The root of 8 is not nice like 2 or 3. It's a decimal. So you plug that in and see what decimal you get. I'm going to give you like 30 seconds because you will be plugging lots of things into Desmos today. Desmos.com. About 20. 10. 5. 3. 2. Okay. I'm getting 7.8. So to make our lives easy, I'm just going to round that up to 8. It's about 8. So I'm going to verify that there is a point around 8, comma 8. So if I go over to 8 and then up 8, I do land on my firework graph. So if the graph were not already there for us, we would connect these points so that it looks like a firework. We would start here, and then we would connect them moving toward the right and put the arrow on the end. Is that making a little bit of sense? Was that a yes or a no? Yes. Okay, so now flip to your quiz. So I believe this is the pink quiz. And number 3 is the same kind of function. So first of all, you don't need to plug in -4 because it's going to be imaginary. You do not need to be talking right now. In the instructions, it tells you to find the vertex first. Well, really, the first thing we should ask ourselves is, do we understand what this graph is going to look like? Well, hopefully yes, because we just did one. He is going to be a closed point with an arrow coming out of it. Well, they tell us that they want us to find the vertex first. And the reason why is because that's your starting point. This is your vertex. Well, that's a lot easier than you might think, because when we did transforming functions, we learned that if it's trapped with the x, we're going to go left or right. Which one did we go in this case? Left. By how many? 3. So -3. And then this tells me that I went up or down. Which direction did we go? Down 5. So the starting point of your firework is at -3, -5. Make sure that it's really at -3, -5, and not accidentally -4. So what you are going to do now is plug in and get the point that's at x is 1, the point that is at x is 6, and sketch your firework with the arrow on the end. So I need to see you get these two values, put those points on the graph, and make the firework. Do you guys understand what you're doing? Was that a yes? Okay, go. Use Desmos, plug in a 1, then plug in a 6. Yes?
So for negative numbers, do we just have to write them in imaginary? Or
Yeah.
Just put the
Well, it's not I, because I is the root of -1, so I would just write imaginary. I'm going to give you like 30 seconds to get started, and then I'm going to come walk around to see what you're doing. Yeah, Julian. How is 3 -3? Because when it's trapped with the x, you go the opposite direction. Go, work, don't talk, or else I'm not going to help you do this assignment. You can do it all on your own. Make sure that the right-hand side is an arrow. It's not a closed point because your firework goes on forever. What are you guys doing? It looks like we need about 45 seconds because most of you guys are done. If you don't have it, you need to make some adjustments because most of the class is already done. So if your table is struggling, you might need to move so that you can get help. Staples, where you at, son? Okay, roughly 30. Yeah, yours done. Is your graph done? Do your graph. You worked out with her. Yeah, see. What? Thank you. Y'all got to get it together. Why do you think that your table, no one at your table is done, but everybody? Okay, I'll stay here and stand and wait. You need to be on your quiz page, and it's the bottom of the, yes, that one, the bottom. Like you need to be out of the graphic calculator. Okay, let's go on to our next graph. So, number 2 in your notes. Number 2 in your notes. So this one is showing us that it is an x squared function because of that x squared next to the 1/2. So if I want to remind myself what this looks like, it is going to be a u. This one's going to be a u. So I can write right next to this problem that this is going to be a u. And the vertex for a parabola is this bottom point. The vertex for a parabola is the bottom point. From our previous lessons, this 1/2 tells me that I'm going to do a shrink, which will end up making my parabola wider. What does the -3 do to your parabola? Moves it down. So what that's telling me is that I now know that this vertex is at 0, -3. It's been moved down by 3. So I can plot that point first thing if I want to. I can write vertex next to it. And now I know that's going to be the bottom of my parabola. So by the time I'm done, I'm going to have something that looks like this. But we want to make it as accurate as possible, so we're actually going to put some points down. Well, it tells us to evaluate this at -6 first, and to make my life easy, I'm just going to do 0.5 instead of 1/2. And then I'm going to plug into parentheses negative 6 squared minus 3. And then as discussed before, Desmos makes this quicker for me to be able to plug in. So if I go to Desmos and I'm on the Windows side, I would type in 0.5 parenthesis negative 6 shift 6 squared, and then I would minus 3. And this is telling me that I have a y value of 15. So when x is negative 6, my y value is 15. So I will put a point at negative 6, 15. And I can put that down right now if I want to. So I would go over on my graph to negative 6. And I would go all the way up to 15. So what I have drawn there wasn't quite right. I did a sketch, but I wasn't quite where I needed to be. Now when I want to plug in my negative 4, Desmos makes this really quick because all I have to do is highlight that negative 6, or just the 6 if you want, and change it to a 4. So at negative 4, my y value is 5. So I have a negative 4, 5. And I can put that point down. So now I can see that I have the left-hand side of my parabola. It's going to come down and it's going to curve. Once you get toward the bottom, it curves. It doesn't go to a straight point. It curves. So there's the first half of my parabola. While we're here, we should probably put an arrow on the end if you're at that point, so that we don't forget, because these parabolas go on forever. We already know the next point because we talked about the vertex. So at 0, your function is at negative 3, or 0, negative 3. And that's this point here. That's the first one we put down. So you guys get the value for 2 and 5. Plug it into Desmos and you guys get the value for 2 and 5. Let's go about 30 more seconds. About 20. 10. Okay, what'd you guys get at x is 2? Negative 1. So positive 2, negative 1. What did you guys get at 5? How many? 9.5. Okay. So 5 and 9.5. So we're going to go to the right 2 and then down 1. And then we're going to go over 5 and up to 9.5. So this guy's weird because he's like in the middle of the square, like he's not on a grid line. Yes.
With the 9.5, couldn't we just run it up to 10?
I would go by 0.5s. So if it's 9.4, I would go to 9.5. If it's 9.9, I would go to 10. Now, when you connect this one, make sure that your bottom is rounded and you don't stop here. Parabolas don't look like this. They don't have one really long side and then one really short side. They're supposed to look like a symmetrical U. So you have to extend that leg up even though you don't have any more points and put an arrow on it. So, biggest takeaway from this problem, make sure that your parabola is curved and that you have arrows on the ends. You're okay on that one? Yes, no? So number 1 is the same on your quiz now. You're on your quiz. Number 1 is going to be the same idea. You have a parabola that's had some transformation happen to it. You're going to plug in those values to try to make your graph. So I would get started and get your values, and then look to see if you can figure out what it looks like. Yeah, make sure that you use parentheses or you'll get something that doesn't look right. Yes, so you do negative 1 squared minus 4 times negative 1 plus 2. Well, where's your vertex? Did you watch me find vertex for everybody? I sure did. Did you get the vertex? I just have to take the hit then. Tough way to learn about listening. Plot your points and then don't connect them until you have all the points plotted.
Because it's a negative number.
I think your negative 1, 5 is not. It's supposed to be up. You can wait to connect it if you want to. No. So just plot your points and then go from there. Like you don't have to connect it, but just at least plot your points. So let's take about another minute for you to just get your points plotted. If you don't know how to connect them, that's fine. but at least put all 5 down. Roughly 30.
See, I was right.
Also, we talked about on these notes how you don't have to have a parabola. Stop there. Like you gotta think about it look like so you gotta connect that one with an arrow. Okay, about 10. 3. Okay, I would just like to say in as loving as a way as possible that like coming around and answering some of your guys' questions, if you were just listening to what I was saying, you would have gotten the answers that you needed. So instead of finishing the problem now and ignoring me, I would maybe listen so that you don't have to look silly when you ask me a question that I clearly went over. So this is what your 5 points should look like. And if you're looking at it going, well, I don't know if that's right, you have 2 options here. The first option is you can go to Desmos in another window. So leave the calculator window up, open a new tab, and go to Desmos again. So desmos.com. So I should see from where I'm standing, all y'all be opening up a new window and go into Desmos again. And under the math tools, this time you're going to choose the graphing calculator. So leave the regular calculator in one window and switch to the graphing calculator in another one. When you go to plug this in, you only plug in what is to the right of f of x. This is what you type in to the bar you see. So if you don't know what I'm talking about, you'll want to look at the window side of the classroom. So I type in x squared minus 4x plus 2, and that's going to show me what this parabola should look like. So now that I have it plugged into Desmos, I have a better idea of how I should connect those 5 points. So I can go back now to that graph and sketch it out so that my 2 sides are long. You don't have one that's shorter than the other. They keep going. And on the ends, you put arrows. So even though I don't have a point up here, I know that it's supposed to look like a U, not like this. Parabolas don't look like that. Give you about 30 seconds to finish up this problem, and then we will go to number 3 in our notes. About 20. 10. Okay, on our note sheet, number 3. The first thing that I want to do is identify what my shape should look like. So this guy is an x cubed. So I'm just going to go back to my parent functions page and remind myself what a cubic function looks like. So I know that he's going to be like a roller coaster. He's going to start pointing down and then move to pointing up. So to evaluate this function, there's a space here for you to do it, but I would not be writing that down. I would just plug it into Desmos and write your ordered pair. So when I go over to Desmos, I'm going to flip back to the calculator and I'm going to type that in. So I have to do 1/20 and then arrow out of that so that you're not in the denominator anymore. Parenthesis, -4, parenthesis. Shift 6, 3. Then plus, so shift equal sign. 1/15. You're going to want to arrow out of that. Parenthesis, -4. And then the last thing you'll do is add on that 1. So I'm getting -2.466, blah, blah, blah. So I'm going to take that to -2.5. So for my ordered pair, I'm at -4, -2.5. Then when I go to plug in this number, -2.55, I'm just going to highlight that 4 and type in 2.55. Then I'm going to highlight the next 4 and do the same thing. So this time it gives me a number that's really, really small. That 10 to the -4 says that it's basically 0. So at -255, my graph is at 0. If I want to plug in the 0, I'm pretty sure I'm going to get a 1. Is your guys' Chromebook going so slow?
Yes.
Mine's going like so horribly slow. It is 1. So by the time I get it, yowzas. So we have a point at 0, 1. Then you plug in 2.55 positive. And 4 positive. Has anybody got it? What's the 2.55? So we'll go to 2. Thank you. And what is it at 4? Do you need a sec for that one? Thank you, dear. 4.5. Okay, now I'm going to put all those points down. So I have one at -4, -2.5. I have one at -2.5 and 0. So this one's -4 and 2.5. This one's 2.5 and 0. 0, 1. 2.5 and 2. 4 and 4.5. So it's like kind of in a line, but not really in a line. And let's say that we're still not feeling super great about how to connect that. Well, then I can just go to Desmos. Well, actually, on your calculator, copy what you have written down here. So copy it so that you don't have to type it in again if you don't want to. So Control C, and then you can go back to your graphing one and paste it there. That's Control V. Instead of having the 0, because that's the last one I did, I'm going to change it to an X. So I just need to replace my 0 with an X. So now I can see how I'm supposed to connect it. It's on my window side. So I know now that this point here is my vertex. At 0, 1, that's my vertex. And if you feel better about sketching it. Don't feel like you have to just go one full fell swoop. So our roller coaster looks like that. Oh, that didn't go well for me. So now we have done a square root, a parabola, and number 2 for the quiz is one of these. And you will need Desmos to help you see how to connect it, because the points are going to look really weird to you. So let's take at least 2 minutes to get that one done. Number 2.